already, I posted right away. So you can review it if you have any question. Okay, so what we are going to do, we are going to get the chapter 1. Chapter 1 is basically all, okay, it's going to be all introduction. So we just go on talking about a few sections of this chapter. The first thing is we want to know what's going to be a statistic really. Okay, so because we are going to study this one. So the question is going to be, what is a statistic? Okay, that's going to be a statistics. You know, the statistics, if you want to get the historical background, it used to be called the science of the state, because the government used this one in order to collect information. In this format, it was used by the Romans for the first time. They just want to know how many house, you know, how many people living in a house and what's going to be their income so that they can tax them. So that's in the old days. And that was the way they operate. But later on, you know, it was for the first time, we just think about the statistics as a science. Okay, it's going to be a science of collecting the information. Okay, you collect the information. Information can be numbers or otherwise, and then you organize this information. You may use some tables, some charts, some graph to put them nicely together. Okay, and then from this information, you may find some common grounds, what's going on, and then based on those so-called small samples, you make a prediction, a generalization. That would be the statistic, okay? So I like to give you just a sentence of the statistics is today is the science, okay? This is going to be the science of organizing, assembling, if you like. Science of assembling, classifying, okay, assembling and classifying, sometimes using some table and tabulating, if you like. Okay, and tabulating information, okay, facts. That's it, facts or data or data. Okay, so that's going to be the you know the idea of the statistic. So when we want to do it, okay, when we want to do it, what we usually refer to it is we have two terms that we're going to use, and that's the first one that's in your book is given to you. One of the terms is going to be a population, okay? So what's going to be this expression that we are going to use? Samples and populations. Population is going to be everybody under your study. So if you want to investigate something about Palomar College, all the students of the Palomar College can be your populations. But since a population is large, so what we do, we are going to collect the information from a small group. That a small group is going to be called a sample. Okay, so you have some problems, you know, they ask you identify the sample and the population. So a population, okay, a population is the collection of everything. Okay, it's going to be the collection of all subjects, if you like, all subjects. These subjects can be human, okay, can be human or otherwise, human or things, if you like. Okay, so it's going to be a collection that are going to be investigated, that are being being studied. So that's going to be the population, everything under your investigation, a population. But of course, the population is very large. So what we're going to do, we are going to pick a sample of the population, a sub collection, or the subpopulation, a subcollection of a population is called, it's going to be called a sample. So get to know them. From now on, these are the expressions that we're going to use. Sample and the population. So the sample is going to be everybody, the nation, if you like, but the sample is going to be just a small region, zip codes, if you like. So that would be the population and the samples. There are some other expressions in your book. They talk about the statistic and a parameter. A statistic is going to be a characteristic of a sample, but the parameter is going to be a characteristic of the population. These are, the terms that we are not going to use it for the time being. We get to chapter 5, we use those. So that would be the statistics, just getting these, that's the old-fashioned one, that, assembling, classifying, tabulating, etc. So this is just the first step, really. And the question is going to be, how are we going to doing these statistical studies, if you like. Or some people believe that there are two types of statistics. They are not types, but they are kind of methods. So you don't have this expression directly in your book, but it's very interesting and very important. So make a note of this one. We may ask you the question of this and the first quiz. So let's see what's going to be types of statistic. So based on these two types, we are going to organize this course. Types of statistic. The types of statistics is going to be, you see what you do when you want to do some statistical studies. First thing, you collect some information. Then what you do, you assemble, classify, tabulate this information that you have. So you start with the sample, and you organize it. For example, suppose you want to know what's the average age of a student at Palmer College. So Palmer College got 25,000 students, with those satellites that you have. So it's a big job. So what they do, we pick a sample. We pick only the sample of a statistic classes, if you like. We go inside the statistic classes and ask the question, how old are you? Then based on this sample, we make a prediction. We predict, if the sample give you something like the average age is 21 years old, 21, then you may predict that, I can predict that the average age of a student at Palmer College is 21 years old. So there are two steps that you have to carry. The first step is regarding to the sample, you collect this information. The next step is based on this sample, you are going to make that prediction. So that's why we call it types of statistics. This is a kind of method that you're going to have. If you just collect the information and you just present it to us, you may find the average of that information as well. If you do only those type of ideas regarding to the sample, your statistic is going to be called, so the first part is going to be called descriptive. That's it. You just describe your information. So what is going to be descriptive statistic? Descriptive statistics is when you do the sample. So what is the descriptive statistics? It consists of, it's consist is going to be consist of methods for those primary job, organizing, okay, organizing and summarizing, and summarizing information, okay, summarizing information related to the sample, related to samples. So that's a preliminary job that you usually do. You may give us a nice chart, you give us a pie chart, colorful, nice one. You're just describing the information, nothing else. But if based on this information, you use some statistical studies, some theorems, and you make a prediction, or generalizations, your job or your method is what? They call it inferential. Okay, this is going to be inferential statistic. That's where we do the main job. Inferential statistics. So inferential statistics is going to be the method that we're going to use, okay, to apply to this information from the sample and make a prediction for everybody, for the population. So this information related to the sample only, but this new one would depend or tell us something about the population. So it consists, okay, it consists of methods, okay, consists of method for generalizing, for drawing, if you like, drawing and measuring the, the truth, the reliability, okay, reliability of conclusions that you have, conclusions about a population, about the population based on the information that we get from the sample. Based on information, based on information obtained from a sample, of the population, sample of the population. Okay, that's a good one that we're going to do in this book. The first 3 chapters would be about the descriptive statistics, but the next 4 chapters is going to be about inferential statistics. How we're going to get the job done. So I emphasize again to just make sure that we use sample information, sample data or information to make a prediction, to make a generalization or a prediction, about the population, That's inferential statistics. As soon as there is an election, you know that. Early afternoon, the CNN say, oh, we are going to predict. We are going to project that somebody is winning the election. So how they do it? In the morning, you go around different polling stations. and they collect the information. So they collect all the information with the method of going around and asking the people. Based on this information, they're just using some statistical studies or method. They predict what is going to be the, the result of the election. So that part, that prediction is called inferential one. You need a tool to be able to do the inferential one. And that tool is probability. So you collect the information first and you extend it to the inferential one. So make sure you know these two difference when doing the course. We describe the information first. You see, this is just a report description. You may find the mean, if you give us the average, but just the average of those sample. For example, in the case of the coronavirus. So remember they talk about these vaccines, effectiveness of the vaccine. And they say, oh, we are waiting for the data. We are waiting for the data. They are waiting for the data because they are in this part. They are collecting the information and they organize it. Based on those data, remember they say, oh, we have a model. See, we check the model coming from outside, a model from Israel or a model from Europe. So this is what they based on their inferential studies, and they predict. They predict that there is going to be a peak for the Omicron, for the next 2 weeks. That prediction is the second part that they talk about it, the inferential one. So get the information first, and based on this information, they are going to make this prediction for you. Okay, that's the procedure that we are going to do it when we go through this course, and we want to make sure you understand it. Okay, any question? I posted a worksheet for you that I'm going to go over it because you don't have a direct example of some of them from your book, or since the book is not available, that would be helpful, especially this first part. So I'm going to check that worksheet for you. Let's just show you. I've already posted, so I can show you again here. That's it's called the worksheet number 1. You are going to have various handouts from now on. That would be help us from time to time. Okay, so this is going to be, okay, so already posted. And you are going to have similar problem, not this first one that I talked about it. You don't have anything from this in your book directly. Okay, can you see this one? This is it. Yeah, we call it a note. That's it. It's this is the so far that I talk about. They say name and define the 2 areas of a statistic. This you can read it for yourself. But the one that we are going to be interested in, this is going to be this number 6. Okay, to give you a good idea, to make sure you understand this notion. Okay, so this is going to be this number 6 we are interested in. So what we want to know, you see, in each of these statements, we wanted to tell us whether descriptive or inferential statistics is used. Okay, descriptive is the one that you just report, you see, information regarding a sample. But the inferential one is the report that involves a prediction, a generalization, okay, if you like. And so I'm going to change this year so that we get something better. You may think about this year is going to be 2025. Okay, this is a very basic, and that's the edition of the book that I used years ago. This is the book by Blumen that I teach from time to time. I teach from this one at Mercostal, and at the university we do this one. And at Palomar I did it before, but since the book for this course was already assigned, so that's why I didn't change it. But it's not bad, at least this part. Okay, so we want to give us an idea. Which one is it? Is it a descriptive statistics or inferential one. So for example, in the first one is in the year 2025, 148 million Americans will be enrolled in an HMO. Any suggestion?
Inferential.
It's inferential, very good. It's inferential because it's based, okay, because it's a prediction. Because they predict in 2025. So they already got some information. They already got some information from the past. Based on those information, they predict something for future. Okay, that's why I changed it. I changed it to 2025 so that you know there's going to be a prediction. Okay, so it's a generalization from the information that we have now for future. So this is going to be inferential statistic. Any question? How about the second one?
Hell no. Soccer. Professor, can you hear me?
Yes, question?
Hi, I have a quick question for you. So for these worksheets that you upload, is that more like something we just do on our own, or is that something we have to like use a PDF converter to
No.
just write on and turn in?
Yeah, you can write it down on it. We need it for the class activities.
I see.
Yeah,
Thank you.
this first one especially because we don't have the examples from the book. Okay, so these are going to be our work activities. No, you don't have to turn it in or anything. You have a similar problems when you get to your assignment and when you get to your okay, to practice quiz and etc. No, not this worksheet. Okay, the worksheet is going to be class activities. Okay, are you ready for the part B? 9 out of 10 on the job fatalities are men. Which one is it?
Descriptive?
Descriptive.
It's descriptive. Yes, very good. Descriptive. It's a report about the sample. Okay, the sample is men working. Okay, and then we collect this information. That's it. So that's going to be descriptive. Very good. Part C, expenditure for the cable industry. 5.66 millions in 1996.
Descriptive.
Again, descriptive, yes. It's descriptive is information from the past. Okay, it's a kind of numerical information from the past. So it's going to be descriptive one. Very good. Part D, the median household income for the people aged 25 to 34 is $35,888.
I think it might be inferential.
Why you think so?
I think because of like it's making like a conclusion like based off of like they gather like the information from like ages people 25 to 34 and it's talking about a median. If or I could be wrong too, I guess.
No, you see, this is again a report only. You see, when especially you can use the median or the mean in the descriptive information that you describe it to us. Okay, so you collect your information. And what you did, you just you find the median for us. Okay, so you use a tool. Use a tool to report it in this format, if you like. So this means you organize your data, okay? You organize your information, and of course, you find the median of your information. So again, still it is what? It is going to be descriptive information, it's descriptive statistic. Because you just tell us something about the special age group. You see? That a special age group is going to be a sample. So when your information regarding to the sample, in that case, this information is going to be, okay, it would be descriptive. That's going to be one. Okay, any question? So it's a kind of report that you're going to give us this report. You are not going to prediction anything. There is no prediction. Since you find the median, this means you already got the information. Okay, you did have your information, you use your calculator, and you find the median of those information. This is all you know, you're reporting, if you like. So that would be statistic. Inferential, that should involve some prediction, some generalization from what you have for the future generation, or etc. Okay, any question? Part E is interesting. Allergy therapy makes bees go away.
I think this is inferential statistic.
Excellent, that's it, it's inferential. Is inferential, you see, the source is prevention. So what they did, so, they already got some information. So probably they find out, many people would have these type of experiences, okay? And based on, they are giving to you, give you a general announcement and a prediction, if you like. So that's generalizations for everybody, and this is going to be inferential. Yes, very good. Part F, drinking decaffeinated coffee can raise your cholesterol.
This is descriptive, I hope.
No,
No, dang. All right.
no, you said just check to see how you find out.
Mhm.
You see, how did you find out that this is going to be the case? And look at the source, American Heart Association. So what they did have some information. You see, for this type of ideas, they already got some samples. They already got some samples. Based on that sample, they measure it and they find out that it raises your cholesterol by 7%. So
Hey,
now,
Professor.
yes,
So, for this one, when I was thinking about this one, I was thinking that it would be inferential because they were making a prediction.
that's it. That's correct.
Okay.
Yeah, it's very good. Yes, it's generalization of prediction. So it's inferential. All these problems related to the medicine, etc., to health, they are going information. They are going to be inferential, because you know that you cannot make this type of a statement without going through it. You see, when you say it's lowering your cholesterol, etc., or raising your cholesterol. So you should have some evidence. The evidence is the experiment that you have carried out. So that's, yes, it's a generalization, it's a prediction, and it's based on some work, you see. So they did some samples. Based on the information from the sample, they are going to predict this one for everybody, you see, for everybody. So that's why this is going to be, okay, it's inferential. So everything related to the health must be inferential. You cannot make any statement right away. Okay, any question?
Professor, I have a question about this one.
Yes,
They made the statement that 10 people were in the sample and that 9 of the 10 people that drank decaffeinated coffee had higher cholesterol. Would that make this descriptive?
yeah. If you, that's it, yes. That's going to be descriptive because you're just reporting about your sample.
Oh, I understand. So the idea that the data in this case is it's a hypothesis about the population
That's correct.
is the difference. And if this were written about the sample, the people that actually drank decaffeinated coffee and had high cholesterol, that would make this more descriptive. Well, this would be a descriptive statistic.
That's correct, yes.
Okay,
Because in that case, you're just reporting something about your sample. You see, since it's related to the sample, those that related to the sample is descriptive all the time. But as soon as you want to relate it to the population, to everybody, or making a general statement, that would be inferential. Yes, very good. Yes. Good. Okay. So that was part F. How about part G? The national average and our medicine expenditure per person is 1,052.
Is it descriptive?
Yes, it's descriptive. It's just a report. Okay, it's just a report that they calculate the numbers and they report it to you. Okay, there is no prediction, anything. When you say 152 means you already got the idea. Okay, you already got the information. So that would be descriptive. Part H, experts say that mortgage rates may soon hit bottom.
Inferential.
That's correct, it's inferential. Because you predict something. You predict something about the mortgage rates based on the information that you have. They say this is what will happen in future. So that's that's a difference between these those two different methods that we have or to describe our information. Okay, any question? So as I told you, we don't have it directly in your book, but this is the way we do it. The procedure that we're going to do is we go through those descriptive terms, if you like, first, and then to get to the inferential, and that would be the nice part of the course when we get to the inferential. Okay, so that's the first thing that we do. I stop this sharing, then I go back and continue, give you more idea, then we come back. Okay, so let's go back and see what else do we have. Okay, just I want to go to my notebook. Okay, let's come back here again. So that would be the plan, if you like. And we know what we are going to know, what we are going to do. So next step is going to be this information that we are going to collect. Okay, so let's go to the information that we're going to collect. We are going to call them data or data. Okay, as I told you, we just do this chapter in general format. So you may see this idea. I think it's a 1.2 or 1.3, but it's not important. Just getting those numbers. So let's see what is going to be the information that we're going to collect. Okay, so the title would be, or this argument is, what's going to be the type of the information? Types of data. That will make 2 questions that you're going to have in your first quiz. Okay, from this section, and you have your first assignment if you do that, that MATLAB one. So types of data or information. Officially, we already talked about the data or data. This term is going to be the information that we're going to collect. Okay, so the data are going to be what? Our observation is going to be observation that have been collected. Okay, so that's going to be the term that we're going to use, the information. So we want to know what type of information are going to collect. So make sure you have enough room to get this classification. So that would be the data. We're going to have 2 different data. If you work only with numerical information, numbers, okay, this is the expression is going to be quantitative, quantity. Okay, so we have quantitative. This is going to be information that we call it or numerical. Okay, numerical information. So the numerical information would be called quantitative one. Then you should be classified, identified bonus. Something like, age or ages, height, Okay, height, weights, salaries, etc. Okay, so these are going to be a kind of a quantitative one that we're going to have. Okay, so quantity, just numbers. There is another description of these, but sometimes informations are not going to be numbers. We call them categorical one. If you talk about blood type, numerical, it's called the marital stat, political affiliation. Okay, these are class categories, they are not number. So this group, we call them qualitative, quality. Okay, so qualitative one. So these are going to be our non, if you like, non-numerical, non-numerical information. The other expression is a categorical one. In your book, from time to time, they refer to this one, category. Okay. So that would be categorical information. So we may have numbers or otherwise. And the example, for example, eye color. Eye color is category, is a group. Blood type. Blood type.
Hey, Professor,
Yes.
if I may say something real quick, one
Yes.
way that I always distinguish them is if you remember like quantitative, like a quantity of something, you
Yes.
can remember that it's a numeric number, and then qualitative, like a quality.
Yes.
That's one way to remember the difference between those.
Yes, very good. Yes, excellent. Okay, just pick something that, enable you quickly to get to it. Yes, very good. Okay, so eye color, blood type, or marital stat, for example. It's a kind of classification, if you like. Marital stats. These are going to be kind of example that we have for the, okay, qualitative one, quali and quantitative, like. Any question? So some statement would be given to you, then you've been asked to tell us which one is it. Is it quantity or quality? No, we have a kind of subdivision of these, and especially for the numbers. When you're working with a number in a statistic, there are two types of numbers that we're going to use. Okay, the first group is you're using counting numbers or natural numbers. 1, 2, 3, 4, 5, 6. If your information using only these type of numbers, we say this information or data is discrete. Dot, 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 nothing in between. So the new group is going to be, so we can, the quantitative one, we change them into the first group is going to be called discrete. Discrete. Okay. In the case of a discrete, you're just using the counting numbers. So using counting numbers or natural numbers. Okay, numbers or just okay, just the natural numbers. The numbers that you are going to use in this case going to be like 1, 2, 3, 4, etc. So you cannot use 1.5 if you like in this case. You're just counting numbers. And there is another way to identify these. When you want to work with this type of ideas, you have to start with the expression of, most of the time they start with this expression, a number of, you see, a number of, you see a number of the cars in the parking lot. So when you say a number of, this means you have to count it. Number of the cars in the parking lot, 10, 20, 13, etc. Number of the pages. So when you see this type of expression, they are referring to the discrete one. Or basically in discrete, you're just using counting numbers, 1, 2, 3, 4, 5, 6. Okay, so that would be the discrete one, because when we get to the other part of the course, we divide our methods, especially in inferential one, based on the type of the numbers that we're going to use. If you use this type of the numbers, it's going to be discrete case, and the machine, the probability machine that we're going to use is called binomial in future. But otherwise, we're going to have different, different system. So the otherwise is going to be if you would like to use any number, any real number, or any number between two given numbers. In that case, the case is continuous. Continuous. In the case of the continuous, you can use any number, okay? So you can use real numbers if you like. That's going to be any number, real numbers. So this means mostly you can use intervals of the numbers. Intervals. So the intervals would be what? Would be any number. Any number. Any number in a given interval. So when you say what's the temperature today? They say the temperature today is going to be between 45 and 76. So this means that during the day, you can have any number in between these two. Okay, or you can say what is the salary in this company? You may say that salary in this company starts from $5,000 and it's going to be up to the $200,000. So any number between 5,000 and 200,000 you can use. So that would be continuous one. Okay, this is kind of a digital one, if you like. That's a digital one, and this is going to be kind of continuous one, old-fashioned watch, if you like. So it's very important for us. Most of the part of the statistics is going to be continuous one. So the variable or the data is going to be continuous, but the other one is going to be discrete, okay? And for the continuous one, we have the machine, we call it normal distribution, that will cover main part of the final part of the course, if you like. Okay, any question? So your job is a list would be given and you identify it for us. Okay, which one is it? And all the problem in that section of the, I think 1.2 or 1.3. But I want to check it with the example that I posted for you. Okay, any questions? So two cases, a quantitative, just the numbers, qualitative, non-numerical, classification, categories. And when you work with the numbers, if you're just using counting numbers, 1, 2, 3, 4, 5, 6, 200, 3,000, it is going to be discrete. But if you can use any number in a given interval, in that case, you are going to have a continuous one, okay, to get these numbers. So your job is a list would be given, and we give you one in your next quiz. Okay, so go back to that worksheet and get quite a lot in your book as well. Just checking numbers. Okay, let's bring it back. Okay, so going back to that worksheet, and the problem that we are going to be interested in is this one, number 8. Okay, look at this number 8. Look at the number 8. And we want to tell us which variable, is going to be just the same as the data. So we want to know which one is qualitative, quality, or is it quantity? Okay, quantity refer to the numbers, quality refer to the categories or okay, or a class if you like. Okay, are you ready? And the first one, number of bicycles. Which one is it, quantity or quality?
Quantitative.
It's quantity, yes. Number of bicycles. Number of the bicycle, 5, 6, 7. So that's quantity. Okay, quantity or quantitative. Part B, colors of baseball caps in a store.
Qualitative.
Quality, yes. Color is class, is categories. So it's qualitative. Okay, qual. Part C, times it takes to cut a loan.
Quantitative.
Quantitative, yes, very good. Times 2 hours, 3 hours, half an hour. Part D, capacity in cubic feet.
Quantitative.
Quantitative, yes. Capacity, in cubic feet, 25 cubic feet. You say the volume is 25 cubic feet. So it's going to be quantity. Okay, part E, classification of children in a daycare, infant, toddler, preschool.
Qualitative.
Qualitative, yes, it's category. Is the classifications, okay, and you have some labels names, so that's a qualitative. Part F, weights of fish.
Quantitative.
Quantitative.
Quantitative, yes, very good. Quantitative because it's just, it's a number. Part G, marital stats.
Qualitative.
Qualitative, yes, yes, it's just category. Okay, category of married, separated, etc., engaged, etc. So that's going to be a difference between the quantitative one and the qualitative one. You get a couple of them in your next quiz and the test. Okay, you just tell us which one is it. Okay, any question? So that was number 8. Now we get to the number 9. Remember, we talked about it when we work with the numbers. There are 2 possibilities. There are 2 possibilities. We may work with the just counting numbers, dot, 1, 2, 3, 4, 5, 6, or we may work with any numbers. So in the first case, we are going to have a discrete case, and the other case is going to be continuous. For the discrete, you have to count it. So you may start with the expression number of. Okay, are you ready? Part 1, number of donuts.
Discrete.
Discrete. Because the number of the donut, you can have 5 donuts. You cannot have 5.5. Okay, so again, you see the expression number of, it's discrete right away. Okay, that's part 1. Part B, water temperature.
I think it's continuous.
It's continuous, yes. It's continuous because water temperature is going to be any number. Okay, so water temperature is between 20 degrees and 30 degrees. So any number can be used. So that's continuous. Part C, weights of cats.
Continuous.
Which one?
Continuous.
Is continuous, yes. Weights of cats can be anything. You see, 10 pounds, 0.2. So that would be weights. It can be any number, so it's continuous. Part D is interesting. Lifetime of the 12 flashlight batteries
Continuous.
is continuous. Yes, it's continuous. You know that when you read the label on the battery, they say 4 hours. But it's not really 4 hours. It's up to the 4 hours. So it can be any number. So in that case is continuous. Yes, it's continuous. Okay, part E is clear. Number of cheeseburgers.
Discrete.
Discrete. As soon as you see number of, you have to count it. 2, 3, 4, 5, 6. So that's a discrete. Part F, number of DVDs.
Discrete.
Discrete.